All right. So I will be taking my face off the video for now because we'll be learning a lot of hands-on for the rest of the slides. So we stopped at the statistics folder. The statistics folder contains 6 other commands. We have list, frequencies, tables, means, summarize, and graph. We would of course be learning the first one, which is called list. Now if you click on the list command, a pop-up window should appear, which looks like this. The default choice under the drop-down box inside the list command is the asterisk. The asterisk refers to all variables. So here, your current choice is all variables, and I want you to let that be. So now, the next step would be for you to click on OK. Now, if you have done that correctly, you should be able to see this line list. Now we know that the list command allows us to browse data in a spreadsheet table. But it's all that it can do. You can't actually edit the data if you would try it. Now let me just go back to some hands-on. Let me switch to hands-on so that I can show you how it is done. So here is the statistics in the project tree, project explorer tree. If I click on list and I click on OK, you see here the asterisk is the default choice. If I click on OK, I would have this separate window, which is a line list of my observations. You would see all of your observations here, and you would see all the variables in the columns. Okay, so now let's go back to the PowerPoint. The next thing that we would learn is frequencies. Frequencies is also found under the statistics folder. What frequencies does is that it allows us to output the frequency distribution of variables. So what we're gonna do is that, let me switch to hands-on. We'll click on frequencies. Okay, let me just close this. Frequencies. And then I'll be getting the frequencies of all variables since it's an asterisk. Let's just click on OK first. So if I click on that, I see the frequencies of every variable that we have inside our dataset. So you can see you have one here for barangay. And what is displayed when in the frequencies command are, of course, the frequency, the counts of observations falling into each category, the percent of each of observations falling in that category, and a cumulative percent. You have a numbers way of presenting cumulative percent and a graphical way of presenting cumulative percent. So you have both of those. Now, as you can see, this is only appropriate for variables that are categorical in nature. Because if you'd be getting the frequency distribution of a variable such as ID number, which actually makes no sense, you'd be getting this very long list. So you have a frequency, you have a row for each possible value under that continuous variable. Sorry, under this discrete variable. Imagine if it's continuous, how many values would you actually have? This one are names, so it also doesn't make sense. If you want to check the rest of the variables, please do so. Our goal here is to learn what the frequency command can do. Alright, so let me switch back to our PowerPoint. Now that is what would happen if you choose asterisk to specify all the variables. But you can also zero in with just one variable. So let me click on frequencies again. And then this time, let me choose barangay. Okay, barangay is already chosen. If you have chosen, sorry, let me do this. If you have chosen the variable on top here, it should be located in this box if you have properly selected it. Now, after you have clicked on barangay, please click on OK. And as you can see, the latest output would be added at the bottom of the previous outputs that you have. So you should be able to see barangay here at the bottom of your output window. The frequency command also gives you the exact 95% confidence limits. You would soon learn about how to properly interpret confidence limits and why they are so important in presenting data. For now, please do know that these are the things that you can actually get if you use the frequency command. And back to the PowerPoint. You've already seen this. Now we learn about the tables command. A tables command should also be located under the statistics command. So what it does is that it outputs cross-tabulation of exposure variable and the outcome variable. So here in our example, I want us to try doing it for the variable sex as our exposure and diabetes as our outcome variable. Let me get onto hands-on so that I can show you. So we have the tables, which is the third command under statistics. And for exposure, we click on sex. And for outcome variable, we click on diabetes. Now, if you have done this correctly, please click on OK. And after you have clicked on OK, you should be able to see this table here and this graphical representation here. Let's focus on the table first. And let me see if that's actually in our PowerPoint so that it would be larger here. So here is the table output that we have from the tables command. And as you can see, there are three sets of numbers. They are frequency, row percentage, and column percentage. Now, you've already had a lecture in tabular presentation, so I expect you to be already familiar with this. The frequency would, of course, be the counts for the corresponding categories, cross-categories of the row variable and the column variable. Row percentage would be the current count for that cell over the row total. And the column percentage would be, of course, the current count for that cell divided by the column total. So please be familiar with this output. Now, you would see on the right side a certain, they are blocks of colors, which actually represent frequencies of the cells inside the table. So you can see the frequencies that we have in the table are 31, 28, 26, and 16. Now, 31 is the largest number. That's why we have this red block as the largest, followed by 28, which is the orange block, followed by 26, and then followed by 16. So if you are getting confused about which frequencies are the largest inside the table, you may just look at the graphical representation. Then the tables command also outputs this single table analysis output. It contains a lot of information which you would be learning soon. Most of this you would learn inside Epidemiology 201. All right, so now we go into our next command, which is means. Now, for means, it's very obvious. Of course, it would output the mean of the variable. And this time, I want us to try it on a variable called age. So please click on means inside your Project Explorer. Then click on means of age. After that, please click on OK. And you should be able to see this at the bottom of your output. Okay, so this is what the means command gives you. It gives you the total number of observations. It gives you the sum of the observations, the mean, which is what you actually want to get. You get the variance, standard deviation, and you get certain measures of location like the 25th percentile, the median, the 75th percentile, as well as the minimum and maximum and the mode. So if you want to get these measures, you would be able to access them using the means command. Now, you can actually output means across categories of another variable. So this time, let's try getting the means of age across categories of sex. So please click on means again, which is under statistics. Means of age, cross-tabulate by value of sex. And then after you've done this, please click on OK. Now, you'd be able to see this output if you have done it correctly. It seems a little bit different from the first one, but what just happened is that the certain descriptive statistics were divided among males and among females, and you have an extra output called t-test and ANOVA. Okay, let me just get back to the PowerPoint. You were able to see this output. So as I have told you, the descriptive statistics portion was divided among males and females. So now you have the number of observations, sum, mean, variance, standard deviation, measures of location, minimum, maximum, and mode among males and among females. Now I want you to be able to compare their means, their variances, and their measures of location across categories. So you should know if I asked, for example, which group had the higher average age, you should be able to answer it using this output. And of course, it would be very easy as long as you are familiar with the different summary measures that we have learned. Now, the extra outputs that we have here are your t-test, which you would learn about soon. How do you use this? What are the set of hypotheses when you're doing a t-test? So on and so forth. And of course, you have another output for ANOVA, which is an extension of a t-test. You would not be learning ANOVA in this course, but hopefully if you would want to, if you would be pursuing to learn more statistics soon, you would be able to learn ANOVA. Because it can be outputted in Epi Info. You also have these certain tests, which are tests for assumptions for analysis of variance. You also have another test called Mann-Whitney-Wilcoxon two-sample test, which is a non-parametric counterpart of a t-test. All of these things that I'm showing you in the PowerPoint, the extra outputs, are just to tell you that they exist. They're just good to know just for now. So what I want you to focus on with this output is that you can output descriptive statistics for each value of the categories of another variable. That is what is important to learn. Now, we go into the next command called graph. So here, we can actually output different types of graphs. And the first graph that I want you to output is the graph of a pie chart. So I want us to choose education as our main variable. So let me show you how to do it in hands-on. You click on graph, which is at the bottom of the statistics folder. You click on pie, and then you click on education. After that, please click on OK. And as you can see, you have outputted a pie graph here, a pie chart, which of course, wherein each slice of course represents each category of our variable education. So here we see that the elementary is the largest. Wait a minute. I'm not seeing the left side of this. It's pushed in, but it really looks like a big chunk. There you go. If you hover over it, you would see the percentage, 27.72 versus 32.67 versus 29.7. So among these categories, elementary is indeed the highest category. Now, what if you want to save this graph that you made? You may click on this diskette, which of course is the universal sign for saving. So you may save the chart as an image in a separate file, so that this window would appear, of course, if you click on the diskette. You may want to print it directly. Just click on print chart, and you can actually configure the chart. When we say configure the chart, you are able to add a chart title, a legend title, an x-axis label, and a y-axis label. So you may do that inside chart configuration. Okay, you have already seen this. Now let's try another graph called scatter. So here you're able to output a scatter plot. I believe that at the time that you're listening to this one, you've already had a lecture in tabular and graphical representation. So you do know what these graphs are for. Now, let me just give you a small reminder. Of course, your scatter plot would be a useful plot to see if there's a relationship between two quantitative variables. And in our example, we would be looking at age and height in centimeters. So let's go here. Let's have some hands-on. Click on graph. Click on scatter. And then click on age and click on height centimeter. Okay. So now that after you have done that, please click on OK. And you should be able to arrive with this output. As you can see, there are the same three buttons that you have in the previous graph, and it functions the same. If you click on the wrench, you'd be able to go to chart configuration and put a chart title, legend title, x-axis label, and y-axis label. If you click on the diskette, you would be able to save this graph. Okay. Now, the scatter command does not only create a scatter plot, but also creates or fits a best fitting line across all points. This best fitting line is actually the regression line if you would be conducting a simple linear regression in on age and height in centimeters. Now this is quite a weird graph because it seems that as you age, the higher the age, the lower your height becomes. Or the higher your height becomes, the lower your age is. That is what the scatter plot says. Okay. I will be leaving the interpretation of this graph to you. I am only here to teach you about the different functions or the different things that the commands can do. So that is scatter. Now I want you to examine column, which allows you to create, of course, a bar chart. And this time, I want RBS to be our main variable. And we would be using another feature of the graph command, which is creating a graph for each category of another variable. So we have main variable RBS, and we want to output one column graph for RBS for each category of sex. Okay, let me show that in hands-on. So you click on graph, you click on column, you click on RBS, and then you click on sex here. And then you click on OK. As you can see, you should be able to output two graphs. You have one for males and one for females. So here, you are able to plot frequencies of the observations for RBS. So in some way, it functions like a histogram, but a bad histogram, since your bins or the ranges of your values, the width of your columns are actually very small in nature. But anyway, if you would want to use this, soon, this is how it works. This is what it can show you. So let me go back with the PowerPoint. Okay, and now we're into our last slide, which is knowing how to actually export or save your data. Now, what I will be teaching you is how to save your data as a PowerPoint. So let me just go back to hands-on. the command would be write export, and write export is under the data folder. So you go to write export. Here you click on replace. Here you click on 97 to 2003, and then connection information. Okay. You might want to have Bioman clean here. And you click on open. I click on OK. And you may want to create a new destination table. So here, what was done is that in connection information, you want to browse, or you want to pinpoint the file wherein you want to save your data sheet. Now, the destination table actually tells you on which tab of the Excel file do you want it to be placed. Now, you can also create a new sheet by adding a new name under destination table. Now, a new tab will be made under the Excel file, which is named new dataset after I am done with this. So let's try to click on OK. Let's take a look now on Bioman Clean. Okay, I forgot where my file was. It's in desktop. Bioman Clean. Okay, as you can see, this is the file that I attached my new tab with. And previously, we only have data, HTWT, high table 1 dataset, and dataset 1 as our tabs. But now we have a new tab called new dataset. And this actually contains the dataset that we have used inside Epi Info. And we still have the variable names at the column headers. So if you want to save your data into Excel, that's how you do it using Epi Info 7. Alright, I believe that I have teach you the necessary commands that you would be needing if you are to use Epi Info 7 in order to present your data. Thank you very much for listening. The main reference for this video lecture is, of course, the Epi Info 7 user guide, which is available online. It's not that updated, but it still contains very much necessary information that would help you into your journey into learning Epi Info 7. There are still a lot of things that you need to learn inside Epi Info 7, but for now, learning about data summarization and presentation is already good enough. Thank you very much for listening. Please feel free to consult me, approach me anytime if you would want to learn more about Epi Info 7 soon. Thank you and have a good day.